At the exact center of our galaxy sits an object so massive that it bends the paths of stars racing around it at millions of kilometers per hour. Sagittarius A*, pronounced Sagittarius A star, is the supermassive black hole at the center of the Milky Way galaxy. It contains a mass equivalent to about 4 million times the mass of our Sun, compressed into a single point. Despite this enormous mass, Sagittarius A* is relatively small for a supermassive black hole, roughly the size of Mercury's orbit. Astronomers first suspected something extraordinary at the galactic center due to strange radio emissions detected in the 1970s. The object was named Sagittarius A* because it sits within the constellation Sagittarius as seen from Earth. For decades, astronomers could not directly observe the black hole because thick clouds of gas and dust block visible light. Instead, scientists tracked the movement of stars orbiting extremely close to the invisible object over many years. One star, named S2, completes an entire orbit around Sagittarius A* in just 16 years, an incredibly short orbital period. At its closest approach, S2 travels at nearly 3% of the speed of light, an almost unimaginable velocity. Tracking these stellar orbits allowed scientists to precisely calculate the black hole's enormous mass without ever seeing it directly. This groundbreaking research earned Reinhard Genzel and Andrea Ghez the Nobel Prize in Physics in 2020. In 2022, the Event Horizon Telescope collaboration released the first-ever direct image of Sagittarius A star. The image showed a glowing ring of hot gas surrounding a dark central shadow, exactly as predicted by Einstein's theory of relativity. Capturing this image required linking radio telescopes across the entire planet to create a virtual telescope the size of Earth. Because Sagittarius A* is much smaller than the previously imaged black hole in galaxy M87, capturing its image was even more difficult. Gas swirling around Sagittarius A* changes rapidly, sometimes completing an orbit in mere minutes, causing significant imaging challenges. Scientists had to develop sophisticated new imaging techniques to account for this rapid variability during observation. Sagittarius A* is currently relatively quiet, consuming very little surrounding material compared to other active galactic centers. Astronomers describe it as an extremely well-behaved black hole, producing far less radiation than expected for its enormous mass. This is in stark contrast to some other galaxies, where central black holes actively devour material and blaze brightly across space. Occasionally, Sagittarius A* does flare unpredictably, brightening suddenly before dimming again within hours. Scientists believe these flares occur when small clumps of gas or dust fall into the black hole's accretion disk. Almost every large galaxy in the universe is now believed to host a supermassive black hole at its center. The relationship between a galaxy and its central black hole appears deeply connected to how galaxies form and evolve over time. Scientists have found a consistent correlation between a galaxy's total mass and the mass of its central black hole. This suggests black holes and their host galaxies grow together through a poorly understood but fundamental cosmic process. Some scientists believe supermassive black holes may have played a crucial early role in triggering galaxy formation itself. Others propose that galaxies form first, gradually funneling material inward until a central black hole eventually forms. The true sequence of events remains one of the most actively debated questions in modern astrophysics. Our Sun and Solar System orbits Sagittarius A* from a safe distance of about 26,000 light-years. At this distance, the black hole's gravity has no meaningful direct effect on our solar system's stability or safety. It takes our entire solar system approximately 230 million years to complete one orbit around the galactic center. This means the last time our solar system was in its current galactic position, dinosaurs had not yet appeared on Earth. Studying Sagittarius A* gives scientists a unique nearby laboratory for testing theories about gravity and relativity. Because it is the closest supermassive black hole to Earth, it remains far easier to study in detail than any other. Future observations aim to capture a video, rather than a single image, showing gas dynamically swirling around the black hole. This would allow scientists to directly watch how matter behaves as it approaches the extreme boundary of the event horizon. Sagittarius A* also serves as a critical test case for Einstein's general theory of relativity under extreme gravitational conditions. So far, every observation of Sagittarius A* has matched Einstein's century-old predictions with remarkable precision. The black hole remains completely invisible to human eyes, detectable only through its powerful gravitational influence on nearby matter. Radio astronomers continue monitoring Sagittarius A* around the clock, watching for the rare flares that reveal its hidden activity. Its existence reminds us that our entire galaxy, home to hundreds of billions of stars, orbits around an object we cannot directly see. Sagittarius A* stands as compelling proof that some of the most powerful forces in the universe remain hidden in plain sight. Every star in the night sky, including our own sun, is quietly falling around an invisible monster at the center of our galaxy, a reminder that even our entire cosmic neighborhood orbits something we can barely begin to understand.